This is SpaceTime, Series 20, Episode 20. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, a new date for the first life on Earth, the star cluster discovery which could upset the astronomical applecart, and plans for a joint Russian-American mission to the planet Venus. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New evidence shows life began on Earth at least 3.77 billion years ago. That's some 300 million years earlier than previously thought, and also places it in the same time frame as when Mars was also a warm, wet world. A report in the journal Nature claims scientists have discovered tiny filaments and tubes which were formed by bacteria that lived on iron encased in layers of quartz. The record-setting fossils were found in the Navajituk supercrustal belt, a strip of iron-rich jasper cutting across the eastern shore of Quebec's Hudson Bay in northeastern Canada. Their formation contains some of the oldest sedimentary rocks known on Earth. It likely formed as part of an iron-rich deep-sea hydrothermal vent system that provided a habitat for Earth's first life forms somewhere between 3.77 and 4.3 billion years ago. And that places it within 300 million years of the formation of planet Earth itself. The study's lead author Matthew Dodd from University College London says the discovery supports the idea that life emerged on Earth in hot seafloor vents shortly after the planet formed. This speedy appearance of life on Earth fits in with other evidence of recently discovered 3.7 billion-year-old sedimentary mounds, also believed to be shaped by microorganisms. Prior to this discovery, the oldest known microfossils were 3.46 billion-year-old samples discovered in Western Australia. To confirm the authenticity of their find, the authors systematically looked at ways the tubes and filaments made of hematite, a form of iron oxide or rust, could have been made through non-biological methods, such as temperature and pressure changes in the rock during the burial of the sediments. But they couldn't find a way that this was likely to have occurred. The hematite structures have the same characteristic branching of iron-oxidizing bacteria found in other hydrothermal vents today, and they were found alongside graphite and minerals like apatite and carbonate, which are commonly found in biological matter including bones and teeth and are frequently associated with fossils. They also found that the mineralized fossils were associated with spheroidal structures that usually contain fossils in younger rocks. That suggests that the hematite most likely formed when bacteria that oxidizes iron for energy were fossilized in the rock. The filaments and tubes were found inside centimetre-sized structures called concretions or nodules, as well as other tiny spheroidal structures called rosettes and granules, all of which are thought to be the result of putrefaction, in other words, rotting biological matter. They're mineralogically identical to those found in younger rocks in Norway, the Great Lakes area of North America, and in Western Australia. Dodd says this discovery demonstrates that life developed on Earth at a time when both Earth and Mars had liquid water on their surfaces. And he says that poses exciting questions for extraterrestrial life. He says that means scientists should expect to find evidence for past life on Mars around 4 billion years ago. If not, he says, it means Earth must have been a special exception. This is SpaceTime. I'm Stuart Gary. Astronomers have discovered multiple generations of stars in a single star cluster. The discovery, reported in the monthly notices of the Royal Astronomical Society, adds to a growing body of evidence that not all stars in a single cluster were formed at the same time. Up until now, astronomers have assumed that star clusters were groups of stars that all formed at the same time out of the collapse of a single molecular gas and dust cloud. Now, because all the stars in the cluster are the same age and were formed out of the same material and therefore of the same metallicity or chemical composition, any differences between the stars in the cluster should only be due to the mass of the individual star. These assumptions have formed the basis of much of science's current understanding of stellar evolution and also for the classification of stars. However, over recent years, astronomers have been observing more and more stellar clusters containing more than a single generation of stars, and that's forcing them to revisit some of their previous assumptions. Now, scientists including Dr. Baizhang Fo from the University of Western Australia and the International Centre for Radio Astronomy Research have identified 15 young stars in old star clusters in the Large Magellanic Cloud, a neighbouring galaxy to our own Milky Way galaxy. Baizhang Fo says the new observations could have important implications for astronomy's existing models of stellar evolution. She says there are over 1 billion trillion stars in the universe, and scientists have been observing and classifying those they can see for more than a century. Therefore, the discovery of young stars in old star clusters could send scientists back to the drawing boards for one of the universe's most common objects. So, that raises the question, how do these young, different stars form? Well, it could have been fueled by new supplies of molecular gas and dust entering the clusters from interstellar space. However, the problem with that hypothesis is that radio telescope observations of the region have not been able to find a correlation between interstellar molecular hydrogen gas in the Large Magellanic Cloud and the location of the clusters being observed. Now, that's led the authors to conclude that the younger stars were probably created out of material ejected by older stars as they die. In other words, it means multiple generations of stars discovered in the same cluster. Right now, the stars are still too faint to see with optical telescopes because of all the dust surrounding them. Instead, they were detected at infrared wavelengths by NASA's Spitzer and the European Space Agency's Herschel space telescopes, which can see through the shrouding clouds. As these young stars continue to evolve, their stellar winds and radiation will blow away all that surrounding envelope of gas and dust. That will allow them to become visible at optical wavelengths to telescopes like Hubble, in the process allowing astronomers to confirm once and for all whether or not these stellar clusters really are containing several different generations of stars. Whatever the outcome, Baizhang Fo says the discovery changes the way astronomers will use star clusters to understand stellar evolution.
There have been quite a debate about how this multi-generation of stars form and how they occur, because as you already said, that globular clusters contain stars that with similar age and chemical composition. So we go and look for some of these clusters, trying to find whether there is the star formation currently happening. If there is star formation that is currently happening, meaning that it is direct evidence showing that it is what is possible to have multiple generations of stars contribute to what we've seen today. So that is kind of what we did. We looked for many clusters in the Large Magellanic Cloud as well as the Small Magellanic Cloud. We didn't find such evidence in the Small Magellanic Cloud, but we did with the Large Magellanic Cloud. So basically, we've found the young star in the star cluster in Large Magellanic Cloud have shown a direct evidence of ongoing star formation.
How did that star formation take place? Are we talking about gas coming in from elsewhere within the Large Magellanic Cloud system, or are we talking about stars within the cluster reaching the end of their lives in the main sequence and eventually dying, and that material being spread throughout the cluster and consequently forming new generations of stars as a result of that?
These two questions, at the moment that we don't know the true answer to that, we do look at the hydrogen, atomic neutral hydrogen gas in the surrounding area of the star cluster and try to see if there is enough gas to accrete it and form the young star. But we didn't see such evidence, not enough gas that accreted. So our theory assumptions and will be further work to do is to look at the contribution from the old star that die and then expose the gas into the interstellar medium and then accrete to form a young star.
So what we're seeing is just a microcosm of what we see in the larger universe in terms of stellar evolution, where stars are born, they live on the main sequence, they eventually fall off the sequence and they die, and that material is then used to make new generations of stars. Do you have spectroscopic information on this young star yet to confirm the metallicity is different to that of the progenitor stars, or the other stars in the system, I should say?
No, the next step would be to do a follow-up of all these young stars and to check the metallicity. Although from what we know that if we go doing spectroscopy, getting more metallicity, we should be able to find more evidence that the metallicity should be different than the old star because they are formed out of a different material.
What do we know about the globular cluster that you've looked at, the one in the Magellanic Cloud?
We look at about 740 of them, and then they all different type of star cluster. Basically, some of them are a lot older, some of them are a bit younger, and then we look at the one that in between 400 million years to 1 billion years, because astronomers have shown that these clusters have a multiple generation. So we specifically go to target this group of star cluster in the Large Magellanic Cloud and try to search for evidence.
Is it difficult when you look at clusters in the Large Magellanic Cloud because of the history of the LMC? It looks like it's been in a pretty bad collision at some stage in its existence. Does that change the cluster, or do the globular clusters within a galaxy that's gone through such gravitational perturbations, are the clusters able to survive those sort of effects reasonably intact?
Our current idea is that that's probably through the interaction have some contribution with the gas. Some of them will survive, and with a collision that is an impact on the gas density that could accreted to form new star, or those that we need more study simulation to confirm that.
That's Dr. Baijing Fo from the University of Western Australia and the International Centre for Radio Astronomy Research. And this is Space Time. I'm Stuart Gary. Okay, time to take a quick break from the show and talk about one of our sponsors. Yeah, there are many times when you can't hold a book, but you can listen to one, such as when you're commuting, when you're at the gym, jogging, or walking the dog. And that's when I listen to Audible. It's my audio bookstore. And you know, I love the idea of someone reading to me. And no one offers a greater selection than Audible. In fact, they've got something like 180,000 titles plus to choose from. Audible's great if, like me, you have an unquenchable thirst for knowledge. Audible means you can learn so much. And right now, Audible has a special deal for SpaceTime listeners. Audible's offering a free audiobook download with a free 30-day trial to give you the opportunity to check out their service. And they've got so many great books to choose from. All the bestsellers, the classics, science fiction, science fact, history, biography, whatever, often from the people who actually wrote them. How about Born to Run by Bruce Springsteen, narrated by Bruce Springsteen? Or The Life of Keith Richards, narrated by Johnny Depp, Joe Hurley and Keith Richards himself. No matter what your taste, there are over 180,000 titles to choose from. To download your free audiobook today, go to audibletrial.com/spacetime. That's audibletrial.com/spacetime for your free audiobook, or just click on the link at spacetimewithstuartgary.com. And now, back to our show. Scientists from NASA are now meeting with their Russian counterparts in the hope of developing plans for what will be a joint mission to Venus. The IKI Venera-D mission is slated for launch around 2025 on either a Russian Proton rocket or its replacement, the Angara. The mission will include both an orbiter to undertake remote radar observations for 3 years and a specially hardened lander capable of surviving the planet's hostile surface for at least a few hours. The team are also looking at trying to fly a solar-powered airship in the Venusian upper atmosphere. The independent flying vehicle will be released from the Venera-D lander as it enters the atmosphere and then independently explore Venus's atmosphere for up to 3 months. Venus has intrigued scientists for decades. It's similar to Earth in composition and size, and also is located in roughly the same region of the solar system. However, unlike the Earth, its day is longer than its year. Venus has always been a mysterious world, hidden beneath a thick cover of impenetrable clouds. To scientists in the early 20th century, Venus's orbit, which is slightly closer to the Sun than the Earth, meant that it would be a warmer world. The clouds mean lots of water, therefore lots of rain, and that meant Venus must have a tropical climate, maybe even covered in thick primordial rainforests. Think of the Amazon or the Congo. And of course, if you have thick primordial rainforests, that must mean you've got dinosaurs. Certainly that was a theme taken up by many a sci-fi movie. In reality, Venus is a hellish, lifeless world. It's often described as Earth's sister planet because of their similar size, mass and proximity to the Sun. However, if Venus is Earth's sister planet, it's somewhat of a twisted sister, with a dense carbon dioxide atmosphere causing a runaway greenhouse effect. That's resulted in surface temperatures of over 460 degrees Celsius, hot enough to melt lead, and crushing surface pressures almost 100 times that on Earth. The planet's surface is shrouded by an opaque layer of thick, highly reflective clouds of sulfuric acid. Any water on Venus's surface evaporated away billions of years ago. When it does rain on Venus, it rains sulfuric acid, and the mountaintops are covered in metallic snow. So, any traveller to Venus, be they human or dinosaur, would be cooked, crushed, broiled, and burnt to a crisp, all at the same time. Glimpses below the clouds reveal volcanoes and an intricate landscape covered in vast, smooth volcanic plains, covering about 80% of the planet. Two highland continents, one Ishtar Terra, lying in the planet's northern hemisphere, and the other Aphrodite Terra, just south of the equator, make up the rest of the surface area. Ishtar Terra is about the size of Australia and includes the planet's tallest mountain, Maxwell Montes, which extends about 11 kilometres above the average Venusian surface elevation. The larger of the two continents, Aphrodite Terra, is about as big as South America. NASA's Director of Planetary Science, Jim Green, says Venus still has a lot to teach science, including whether the planet may once have had oceans and harboured life. By understanding the processes at work on places like Venus and Mars, science will have a more complete picture about how terrestrial planets evolve over time. And that will allow them to gain better insights into Earth's past, present and future. By studying how Venus's climate operates, scientists hope to understand the mechanism which has given rise to the rampant greenhouse effect seen on Venus today. But getting to the surface of Venus has been a difficult task. The former Soviet Union sent more than a dozen probes to study Venus between 1961 and 1984. In 1967, the Venera-4 touched down on the surface of Venus, becoming the first spacecraft to achieve a soft landing on another planet. Then in 1970, Venera-7 briefly managed to send back the first images from the surface of Venus before the spacecraft was destroyed by the planet's extremely harsh environment. All in all, the Soviets managed to land 10 probes on the surface of Venus with varying degrees of success. The extreme conditions meant the first ones only survived for brief periods of time, if at all, and even the longest survivor only lasted 127 minutes. Over the years, the design of the 5-ton Venera landers continued to evolve based on previous experience in order to better deal with the extreme temperatures and pressures on the Venusian surface. The designs included a spherical compartment to protect the electronics from atmospheric pressure and heat for as long as possible, a shock-absorbing crush ring for the landing, and roof-mounted antennas and aero braking structures. All the probes were designed to operate on the surface for a minimum of 30 minutes. However, most of them failed to achieve that. Instruments varied on different missions, but almost always included cameras and atmospheric and soil analysis equipment. Some included microphones, drills and surface samplers, seismometers and instruments to record electrical discharges during their descent through the Venusian atmosphere. Cameras, however, often proved to be a serious problem. Incredible pressures and heat meant lens caps often failed to release. And when they did release, it wasn't always a good thing. The Venera-14 spacecraft had the misfortune of ejecting the camera lens cap directly under the surface compressibility tester arm, resulting in data on the compressibility of the lens cap rather than on the planet's surface. But while the Russians have spent most of their interplanetary time focusing on Venus, they haven't been the only ones to visit. NASA first visited Venus with the Mariner 2 mission during a flyby in December 1962. The agency's last dedicated mission to explore Venus was Magellan in 1990. It spent 4 years using radar to map some 98% of the planet's surface, with resolutions down to 100 metres. The most recent spacecraft to visit the planet was the European Space Agency's Venus Express mission. It launched in 2005 to observe the Venusian atmosphere and its dynamics. It lasted in orbit until its final suicidal descent into the planet in 2014. This is SpaceTime. I'm Stuart Gary. Arianespace has successfully launched the Sentinel-2B Earth observation satellite, which will monitor the worsening changes being caused to our planet by global warming. The spectacular nighttime launch blasted into orbit on a Vega rocket from the European Space Agency's Kourou spaceport in French Guiana.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage P80 et décollage. La propulsion est nominale. Paramètres à bord normaux.
And we're off. Sentinel-2B is on its way. Vega
Les paramètres à bord sont normaux, la trajectoire est nominale.
blazing a trail across the equatorial skies over the Guiana Space Center, heading north out over the Atlantic. We're just getting the rumble, the sound, if you like, of the launcher here at the Mission Control Center. The job of the first 3 stages is to get us away from the Earth. Vega's pushing itself away from gravity, and we're burning the first stage. It's called the P80. That's because 80 is standing for the amount of propellant, 89 tons, in fact. Our altitude is 35 kilometers above Earth. We're traveling nearly 2 kilometers per second.
The 30-metre tall Vega launch vehicle is designed to carry lightweight payloads between 300 kilograms and 2.5 tons. Originally developed by the Italian Space Agency, the Vega uses 3 solid rocket stages and a 4th liquid-fueled stage for orbital manoeuvring and fine adjustment.
Acquisition de la télévision lanceur par la station de Saint-Jean. Séparation P80.
We've
Allumage du Zéphiro 23.
separated the P80 and lit the engine now on the Z20E20.
The Vega's first stage was jettisoned 1 minute and 55 seconds after liftoff, followed by the second stage at 3 minutes and 39 seconds, and the payload fairing 17 seconds later.
Now, right now, we are flying like the wind, burning the Z for Zéphiro second stage, and
Séparation
now
du Zéphiro 23.
about to switch on the Z9, Zéphiro 9. And the next
Séparation de la
phase,
coiffe.
separation of the fairing, which we don't need anymore because we are 131
Les
kilometers
paramètres à bord sont normaux, la propulsion est nominale.
above our planet, and we don't need it because there's hardly any friction.
The third stage was jettisoned 6 minutes and 32 seconds after launch, leaving Vega's upper stage to deliver the Sentinel-2B into its sun-synchronous orbit 57 minutes and 57 seconds into the flight. Telemetry links and attitude control were then established by mission managers at the European Space Agency's Operations Centre in Darmstadt, Germany, allowing activation of Sentinel-2B systems to begin and its solar panel to deploy. The 1,100 kilogram Sentinel-2B is the 5th spacecraft in Europe's Copernicus constellation. The Copernicus project includes a fleet of Earth-orbiting spacecraft designed to provide continuous autonomous high-resolution global observations studying the effects of climate change caused by human pollution on the environment. Like its sister satellite Sentinel-2A, the new Sentinel-2B spacecraft is equipped with a high-resolution 13-band multispectral optical imaging camera monitoring vegetation, soil and water cover over both inland waterways and coastal areas. The Sentinel-2 twins will also provide information for emergency services. They're being positioned in 290-kilometre high orbits on opposite sides of the planet to provide total global coverage every 5 days. Other satellites in the Copernicus constellation include Sentinels 1A and 1B, which carry C-band synthetic aperture radar imaging systems to provide all-weather day and night coverage over both land and ocean. Sentinel-3A, the first of 2 Sentinel-3 spacecraft, is already in orbit undertaking oceanography observations. Sentinel-4, which will launch in 2021 as part of the Meteosat weather satellite, will study the planet's atmospheric composition from geostationary orbit. A Sentinel-5 precursor mission, slated for launch in 2018 as part of the payload aboard the METROP-C spacecraft, will monitor atmospheric composition from low Earth orbit. It will be followed by a second more advanced standalone Sentinel-5 satellite in 2021. The final satellite in the series, Sentinel-6, will carry high-precision altimeters to monitor rising sea surface levels as the full effects of man-made global warming start to take hold. The Sentinel-2B launch was the 3rd this year for Arianespace, the commercial arm of the European Space Agency, which is planning a total of 12 launches this year. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.